NASA may have just approved one of its boldest Mars concepts yet. Music, a nuclear-powered spacecraft called Space Reactor 1 Freedom, designed to launch before 2029. Not a human mission, at least not yet, but a real deep space test of a fused-ion reactor powering electric thrusters while carrying a fleet of Mars helicopters as cargo. If this mission succeeds, could Mars travel evolve into something closer to routine supply runs? And once nuclear propulsion becomes operational beyond Earth, who joins the race next? In this music video, we're breaking down the mission, the technology, the dangers, and the questions nobody is openly asking. Let's begin. What NASA revealed. NASA's latest Mars project is not another rover landing or flashy astronaut announcement. Instead, it's an experiment built around a single idea. Can a nuclear-powered spacecraft survive and operate reliably in deep space far beyond controlled laboratory testing? The project is known as Space Reactor 1 Freedom. On the surface, the concept appears surprisingly straightforward. A compact fused-ion reactor launches into orbit, activates only after reaching deep space, and begins producing electricity for highly efficient ion thrusters that slowly push the spacecraft toward Mars. The acceleration will be gradual, building over months rather than seconds. No massive fireball, no thunderous propulsion burn, only a constant electric thrust designed for endurance and efficiency instead of raw speed. In many ways, it resembles an interplanetary cargo engine more than a traditional rocket, and that's exactly what NASA appears to want. SR-1 Freedom is not expected to transport astronauts. Its primary payload is believed to be a technology package called Skyfall, a swarm of lightweight Mars helicopters intended to explore dangerous terrain that conventional rovers struggle to reach, including cliffs, crater walls, and unstable debris fields. Yet the true focus of the mission is not the helicopters. It's the spacecraft itself. Future Mars exploration will require far more than a single crew capsule. Missions will eventually depend on cargo systems, habitats, music, communications relays, power units, supply networks, and return equipment staged across deep space. Music. If nuclear electric propulsion can transport heavy cargo more efficiently than chemical rockets, it could completely reshape how Mars missions are planned. But operating a fused-ion reactor in space is far more complicated than using small radioactive batteries like previous probes. Nuclear reactors introduce shielding requirements, heat management problems, system failure risks, political resistance, and countless disaster scenarios that have ended similar concept before launch approval. SR-1 Freedom could become the mission that finally proves whether these systems belong in reality or remain trapped as theoretical engineering projects. Why nuclear propulsion changes everything. The challenge of reaching Mars is not only about distance. It's about time, mass, and long-term human survival. That's why nuclear propulsion keeps returning to NASA's future mission studies. Music. Chemical rockets remain unmatched during launch, providing the explosive force needed to escape Earth's gravity. But after a spacecraft enters deep space, every kilogram of fuel carried to increase speed also increases total mission mass, complexity, and cost. For astronauts, travel time becomes a serious biological problem. The longer humans remain exposed to deep space radiation and microgravity, the greater the damage to muscles, bones, and overall health. Reducing travel duration is not simply convenient. It could become essential for survival. That's where nuclear thermal propulsion enters the discussion. By using reactors to superheat hydrogen fuel, spacecraft could potentially travel much faster than with traditional chemical systems, cutting months from Mars missions. SR-1 Freedom, however, focuses on a different strategy: nuclear electric propulsion. In this system, the reactor does not directly create thrust. Instead, it continuously generates electricity that powers ion engines capable of operating for years. The thrust is extremely small, but incredibly efficient over long periods of time. Ideal for moving cargo through deep space, though far too slow for rapid crew transport. NASA's future Mars strategy could eventually combine both systems together. Slow nuclear electric cargo ships delivering habitats, food supplies, vehicles, and infrastructure in advance, followed later by faster nuclear thermal spacecraft carrying astronauts on shorter missions. Even then, nuclear propulsion alone cannot solve every challenge tied to Mars exploration. Radiation exposure, planetary landings, and life support systems remain enormous obstacles. But if these engines can dramatically improve efficiency and reduce travel demands, they may transform Mars colonization from a distant concept into something operationally realistic. What happens next? Announcing a nuclear-powered spacecraft is one thing. Successfully flying one is where engineering, politics, music, and risk management collide. SR-1 Freedom is not merely a reactor attached to a spacecraft. Music. It is an interconnected system where every component must function correctly for years while operating hundreds of millions of kilometers from Earth. The reactor must activate safely and remain stable while powering a closed-brain energy system capable of generating more than 20 kilowatts of electricity. That energy has to continuously support high-voltage electronics and ion thrusters, music, while massive radiator systems remove excess heat into the vacuum of space where no atmosphere exists to absorb it. The spacecraft also has to protect its own electronics from radiation exposure, regulate internal temperatures, manage electrical fluctuations, music, and survive system malfunctions without direct human intervention. Music. Every one of those systems must pass strict safety reviews before launch approval is even possible. Launching halo fuel into orbit requires extensive accident modeling. Engineers must calculate what happens if a rocket explodes during ascent, if a launch stage breaks apart, or if the reactor experiences forces outside its design limits. Final authorization could require approval reaching the White House itself, music, and even a small delay could shift the planned 2028 launch opportunity into 2029 or later. If SR-1 Freedom succeeds, the mission could provide something more valuable than headlines: real operational data. Scientists would finally see how nuclear reactors, radiators, and electric thrusters, music, survive long-term exposure in deep space. It would also establish precedent, creating experience for regulators, manufacturers, and engineers who may eventually build more advanced nuclear spacecraft faster and more confidently. Music. The long-term implications could extend far beyond Mars cargo missions. Future outer planet exploration, deep space infrastructure, and high-power missions operating where solar panels become ineffective may all depend on technologies like these. Music. The biggest uncertainty now is no longer whether the concept is theoretically possible. It's whether NASA can maintain funding, satisfy safety requirements, stay on schedule, and turn a single experimental spacecraft into the beginning of an entirely new generation of nuclear-powered space travel. Outro. SR-1 Freedom will not carry humans to Mars, but it could become one of the most important technology demonstrations ever attempted for future exploration. If nuclear electric propulsion proves itself in deep space, it may eventually support larger cargo operations and power systems needed for sustainable missions beyond Earth. The hardest problems of Mars exploration are still unsolved, but this mission could become one of the first real steps toward making long-term exploration possible. Enjoy. Heat.